We'll go forward. All right, here we go. I might. Probably. We'll probably use this one. Oh, is it? Who's it for?
It's for taking.
Okay, but I definitely need that back. I mean, we don't need that back. Right? There we go. Okay. So, starting over. All right, so going forward, I think especially for today, we're definitely going to need to. I want just the recording of the lesson.
You can minimize it, I think.
Yes, you can. Thank you, sir. All right. Okay, so here's what's going to happen. Today, we start our test review. We're going to continue it on next Friday. The test is the 19th. So on the top it says, test will take place next class. Cross it out, right? Test will take place 10/19. I just want everybody, so go back to the very first slide. It says test review. Test is 10/19. Back. I will go to you any second. So in your class, 10/19. All right, period 3. No. Actual test. Yeah. It's not the, unlike the add-on activity where that was a different story. And I think there were a couple of you who did not need to do it because you did so well on the test. So think about it like this. The harder you work now, you will get rewarded later in one way, shape, or form, which might be less work you need to do. All right. First up, we're going to talk about are the angle relationships. So what we have going on is the following. Well, we're just identifying. We're just identifying what type of angles we have. So in this case, this first problem was identify the alternate exterior angles. So look at our diagram, the alternate exteriors. Who could tell us? So alternate exterior. Is alternate the same side or opposite side? Anybody remember? Opposite, that's right, Zoe. That's right, Jason. Alternate means opposite. And then what does exterior mean? Inside or outside? Say it.
Outside.
Outside. Opposite, outside. Remember, we can say outside, inside, outside. So now, given that, who could tell us? Well, let's pick it. I got a better idea. Let's pick at least one angle that is outside the two parallel lines. Pick any one of the 4 angles that are. Okay, we can do that. I like that. So Des said 2, angle 2. and angle 8. So that's one example. That's perfect. 1 and 7 also work as alternate exteriors. Yeah, because 1 and 7, 7's outside, 1's outside. So angle 1 and angle 7 would also work. So those are two possible types. Now, what do we know about alternate exterior angles? What's the relationship? Who remembers what the relationship of the alternate exterior angles are? They are congruent. Alternate exterior angles are congruent. Yeah, you could say 1 and 7, 2 and 8. They would also equal each other. That's right. You don't have to do this for this particular activity, but yeah, it's good to know. Because when we deal with some of these problems later, that's exact. You're going to need to know. Okay, I have alternate exteriors. They are congruent. You set them equal to each other. So they are congruent. Because later today, we're going to talk about those types of angles. Now, what we're going to do, we're not going to do every problem. We are going to skip around and do it. We'll probably go with every other problem for now. And then if there's time, we might backtrack. So does everybody understand what our game plan is for today? We're not going to do all the problems right now. But we're not going to do them all in order. We'll do some of this type, some of where you have the expression set them equal or add to 180. And then we'll deal with some lines, the linear equations. All right, so don't be surprised. That's why I need everybody to stay focused. Keep paying attention because we're not going to do all this. We're going to go out of order a little bit. I'm going to tell you that right now. All right.
Whoever is covering the green sheet that
That's for 5 and 7. All right.
So whoever is going to be the covering, give them that and then business.
Okay. Goodbye. All right. That's number one. Questions on number one. All right. Again, video is probably going to get posted later overall with notes of what we completed. Again, maybe it's not going to be all of them in order. They're going to be some problems here, some problems here. It's going to alternate, okay? All right. All right. Real quick. Well, we'll just say one clue and then we're going to go back to this one later. Alternate interiors. What do we know about alternate interiors? Who remembers those?
It's the angles on the inside.
Inside. Is inside and what else?
Opposite.
Opposite as well. Opposite and inside. That's outside, inside, outside. So now, pick any one of the four that's inside. Pick any one of the four angles inside. Just pick any one of the four.
4.
Okay, so we have angle 4. With angle 4, which other angle do we pair up angle 4 with to have alternate interior angles?
6.
That's right, 4 and 6. 4 and 6 are paired up, then what other pair do we have?
3 and 5.
3 and 5.
3, 5. Now, what else do we have going on here? If there are alternate interior angles, you have congruency. Congruent. Questions? All right. Let me see what the next problem is. Because again, some of them we might skip. So we'll go with 1 and 2, right? Okay. I do want to do 3. But we might skip 4. Let's see what we have. Consecutive interiors. Similar to alternate interior, we have to look at the inside. In, out, or out rather. However, consecutive interior, is it going to be opposite side or the same side? Same side.
So our angles would be 3 and 6, 4 and 5.
Yup. Inside, inside. So angle 3, angle 6, angle 4, angle 5. Now, if the consecutive interiors, what's the relationship? Add up to what?
180.
That's right. Add up to 180. And some of us on our quiz struggled either knowing, oh, wait a minute, these two angles add up to 180. So yeah, these guys add up to 180. Boom. Angle 3 plus angle 6, 180. I should say measure. And the same thing, measure of angle 4. Let's measure of angle 5. 180. That's another important factor to note. All right, questions on this problem? Consecutive interiors. Add up to 180. And usually the same side inside. All right. What about number 4? Given the following diagram, which pair of angles are vertical angles? There's only going to be one possible option. In the end is C. Well, why did 3 and 7 not work?
Because they're like, one's in the inside and the other's in the outside.
Okay. So yeah, like, all right, so 6 and 8 would be the ones. Yeah. Yeah, it's sort of like the Charlie Brown, yeah. Kind of like that idea. Yeah, 6 and 8, they're the vertical angles. Because 3 and 7, the same spot. So those are corresponding. And that's why that other quiz, the Charlie Brown idea worked because you do your zigzag, 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 zigzag. You would have gotten those 4 measures correct. And then 2 and 8, alternate exterior. 1 of 7 is also alternate exterior. So yeah, choice C would be correct. Good job. The vertical angles are opposite each other. But what else do we know about vertical angles? What about their measurements? Yeah, they're going to be equal measurements, so they're going to be congruent. So they will have equal measures. Very good. All right, questions on number 4. Again, these are what we put in these extra notes. Again, you don't have to write them all if you understand what's going on, but if you're not sure, we still need to understand the relationships with our angles. If we want to, if we want to like figure out what else we need to do. Okay, number 5, linear pair. This is where quite a few of us made mistakes on our last quiz. Linear pair. What would work out of these 4? Say again? YD. All right, that's exactly the reason why. Right there, on that straight line. The other 3 would not work because 3 and 5, alternate interior. 2 and 4 are vertical, along with 6 and 8. So, angle 1 and 4, that's your linear pair. Now, so you said they were a linear pair, they form a straight line angle. If the 2 angles form a straight line angle, what must the sum of those 2 angles add up to be?
180.
Yes, perfect, Catherine. That's something we all need to remember. Not only you have a linear pair, but the linear pair, they add up to 180. So again, measure of angle 1 plus measure of angle 4 is 180. You have to know that. Because that was another part of that quiz where some of us, I gave you one of these 2 angles. Basically, you had to give me the 7 remaining, and we were not sure. We did not add angle 1 and angle 4, angle 2, angle 6, or whatever. That did not happen for quite a few of you. We're losing some serious points. All right, questions on number 5. What about number 6? Which pair of angles are corresponding angles? Okay, one person is saying C. 4 and 8. Agree or disagree with that 4 and 8? One person agrees. 2, 3. Okay, who can tell us why 4 and 8 would be the corresponding angles? Why is that? Yeah? Perfect. Same side, same spot. Yeah. That's a winner. Because this one, 3 and 6 are not, they're consecutive interiors. Two and 4 are vertical. 1 and 8, they have a different type of relationship. So, see, now if they're corresponding angles, what else do we know about, since, now, you will be told the two lines M and L are parallel. But what else do we know about angles 4 and 8 if they're going to be corresponding and the lines are parallel? Grown as well. Angle 4, angle 8, measure of angle 4 will be congruent to the measure of angle 8. They'll have the same measure. Very good. Thank you. Questions on these first 6? All right. Now going forward, we're probably going to be doing every other problem. We're not going to do, because I don't want to waste time going over the same stuff double. It's going to be we do one, and then you do the other on your own. So that's what I think we're going to have going forward, because I don't want to do only half. And then the other half, we wait till next week, and then we're going to forget the first half. So we're going to alternate going forward. And then when we come back next Friday, and we're going to look at the ones we didn't do. I mean, you could try the ones we didn't do at home, because we're not going to see each other for a week. And then from there, we come back. All right. Okay, 7A. And it's sort of like what we were talking about with the first 6 problems. You have a line. Crosses M and N. M and N are both parallel. Angle 1 is 53 degrees. We have enough information to get the remaining 7 angles.
Yep.
Okay. Well, which angle do you want to give right away? What other angles do we immediately know right off the top?
3,
Okay, what would angle 3 be?
53,
Because
zigzag,
Charlie Brown.
Charlie Brown zigzag and
no,
what other, well, begins with a V. What type of angles are angle 1 and 3?
vertical.
Vertical. That's the winner. But yeah, that's a nice way to think about it, the Charlie Brown idea. Snoopy, he has his own mind. He goes here, there, and everywhere. Well, not that I'll never diss Snoopy. Don't get me wrong. I will never diss Snoopy. If I do, then that would not be cool. All right. So we have 53 degrees for angle 3, 53 degrees for angle 1.
53 degrees for 5 and 7.
Okay, that's going to work as well. And we have several reasons, because with 3 and 5, what type of angles are 3 and 5?
Vertical.
Careful, 3 and 5. This side, alternate interiors, very good. And then 5 and 7, well, 7 would also be 53 degrees. And there's a variety of reasons. Because with angle 5, they're vertical. Angle 3 corresponding. Angle 1, alternate exterior. So there's several reasons why. If it's 53 degrees would be the correct answer for angle 7. You have multiple reasons. I mean, the quickest way we talking about was the Charlie Brown idea of zig, zag, zig, zag. Now, what about angles 2, 4, 6, and 8? Yes, Captain.
You do 180 minus 53.
180 minus 53 for these. Yes, very good. Careful.
55.
7. It's 157.
127. 180 minus 53. 127. Now with angle 2, with respect to angle 1, what's their relationship, angle 1 and angle 2? So angle 1 and angle 2, look what they form.
Linear.
A linear pair. And a linear pair, you get, well, letter S. What word describes a linear pair?
Straight.
That's another word.
Supplementary.
Supplementary, yeah. But we have, so those are reasons. And then once you have angle 2 is 127, do you know what angle 4, 6, and 8 are going to be?
Yep.
127.
They're all going to be 127 as well. And again, you will get a test question of this type. I promise. You will get a question like this. All right. Question on 7A. Now, 7B, you're going to work on your own. You try on your own. So, this one we're not going to deal with now. But whatever you did for 7A, you're going to do the same thing for 7B. So, we'll do this one next time. So, we're going to skip that problem now, because some of you already know how to do it, but if not, that's okay. This is one of those you try at home. I know it's gonna be a full week before we meet again. All right, number 8. These are the ones we're going to talk about a little bit. We're not going to do all of them for now. We're probably going to skip and return. Now for number 8, what is our angle relationship between the two angles? You can tell us. What would be the relationship between those two angles? This one here, this one there. Or I should have put the dot right here. What's the relationship between these two particular angles? Look at their location. First off, go ahead.
They're both inside.
That's a good start. They're both inside.
Alternate interior.
Why alternate interior?
And they're the opposite side and inside, so.
Bingo! That's a winner. That's alternate interior. You got it, Jason.
Just think of this, like think of yourself and then alternate self. It's like the opposite of you.
Okay. And then plus with a mirror?
Yeah.
All right,
Alternative reflection.
okay. All right, we can work with that. So yeah, they're alternate interior. So then what do we know about the measurements between these two angles?
And congruent.
So that means
They equal to each other.
they're equal to each other, that's right. You have 13x plus 9 is 14x plus 2. Now I think the spacing wasn't the best, but once you get this part, can we solve for x?
Yes.
I want you all to try to solve for x real quick on this one. I'll give you all a minute or two to try to solve for the x.
I got 7.
Okay. So x is 7. Anybody else get an answer yet? Okay, 7. Anybody else? Okay. H. We're not doing that problem. Okay. Just to make sure. So I heard about three of us said x equals 7. What will be our first step here?
Subtract 13 from 14.
Subtract 13x on both sides. Good. Your first step's always a free move, ladies and gentlemen. Whenever you have this type of problem, first step's always a freebie. And it's better to move the smaller x. And what's really nice is 9 equals, what's 14 minus 13? 1. And we just need the x, that's all. And then a plus 2.
And subtract 2 from both sides. 9 minus 2 is 7. That's what I said.
All right, so we have 7 equals x. Very good. All right, now, what would be the angle, in this case, just measurement? I should have put the parentheses around the s. And here it's only going to be just one angle measurement because we know they're going to be the same, right? So what would be the angle measurement of either angle? Okay, Des is saying 100.
Let me see.
So you do either 14 times 7 plus 2 or 13 times 7 plus 9. 98 plus 2 or 91 plus 9. Grand total is all roads point to 100. That's 100 degrees. And then, of course, we could get all other angles too. Oh, do we have to? No. Okay, questions on that problem? Now, I know it's out of order a little bit. I want us to talk about number 10, which is right below. Before we do that, any questions on number 8? Anybody got any questions on number 8? You all got that one?
Yes.
All right. Ladies in the back, did we get that one too? Again, watch your signs, watch the math, because someone's made mistakes. All right. Number 10. This pair of angles. Who can tell us first the relationship? So number 10, what's the relationship we have going on here? Consecutive interior, very good. Des is right, that's a consecutive interior. Okay, now I have an equation. So what's the equation? What's going to happen, I should say? Whoops. It's consecutive interior angles.
What did they just add up to?
They add up to 180. Very good. That's the most important part. Add up to 180. That's the most important part of this whole problem. You set both expressions, 3x plus 5 is 2x minus 15. You don't have to put them in parentheses, but the sum of those two angles will be 180. Now, unlike the previous problem, our variable terms, so unlike the previous problem, I'm going to just step back for a second. You know how we had our x terms on opposite sides, correct? So I'm just stepping back for a second. For number 8, we had the x on one side, the x term on the other. That's when we had to take the opposite sign. Unlike number 8, number 10. Number 10. Where do we see our x terms?
We have x in the 2
Okay.
equal 5x.
Why are they going to equal 5x?
Because you just add them together.
That's right. Because we added together because they're on the same side. Very good. In this case, you add them up. And then what's going on with the negative 5 and the negative 15? Yep, we're going to combine them as well. Bingo. You got it, Andy. Negative 20 it is.
So wouldn't it be 5 times plus negative 1?
No, you add them.
Well, you could say 5x plus negative 20 or 5x minus 20.
So either,
So you're saying, I just want to make sure you got it right.
no, it's because you didn't write the plus sign, so that's why I'm asking.
Oh, like right here?
Yeah, that's why I'm asking. It's going to be 5x minus 20 or 5x plus negative 20.
Either expression would be the same. So if you had wrote it, that's okay. It's not wrong.
As long as the parentheses are.
Yeah. Because I know you might get confused with signs. Or, let's say, 1 second, Edwin. Well, what, Edwin?
Yeah.
Do it. Okay, I see what you're saying. So if we did this, now, technically it's the same, we just have to be careful when,
I get the same answer.
if we solve it correctly, like up here, we have plus negative 20. Now,
We subtract one, subtract negative 20.
well, we would subtract negative 20, which in the end would be the same as, what's really taking place when you subtract the negative?
Subtract negative one.
Yeah, when you subtract the negative.
I see.
All right, no worries. When you do that, that's actually in the end gonna be, it's gonna just be one big positive number.
Oh, that.
So plus negative, we're just gonna cut to the chase, make it just negative, or minus sign.
So it's a plus, would be plus. So it's not negative 20 anymore, it's a positive 20.
Are you talking about here?
No, like.
Up here?
Yeah, would it be a plus 20? If you do,
The opposite?
yeah.
Yeah. Yeah, then it will be a plus 20. Because you have to go with this sign.
Yeah, 20 to
So then-
negative 12.
So then, let's say we start with subtract. It's 5 times negative, yeah, that, would it still be positive 20?
Yes. It will be positive 20 here.
So when it's, positive negative 20?
No, because you're gonna have to follow the sign closest to the number. So like right here, you follow the sign closest to the number. So that's, this one wouldn't matter. It's, yeah, sign of the closest number.
So we go 190. 180 plus 110.
Careful, careful.
Okay.
I did, yeah, and then I got 200.
200.
270.
And then, you divide by 5, and I got, 40.
Perfect. That's a winner, Andy. Good job. Your X is gonna be 40. Excellent work. So then X is 40.
And you have to do 3 times, 3 times 40 minus 5, and 2 times 40 minus 15.
Yup. So your angle measurement's perfect.
Would it be the same answer if I applied both of them?
Actually, you're gonna get two different values in this case.
The first one I got 130. For 3 times 40 minus 5. Oh no.
Equals to 50.
115.
Okay?
I got 65. So.
Yup, that's gonna work. Because in the end, if you add 115,
Plus 65.
what do you get?
180.
Bingo. That's the way to check. Well done. Well done, team.
So in the angle measurement, do I put 180 or?
You put the two numbers separately, the 115 and the 65. Very good. Okay, any questions? On the second problem here? All right. So really quick, I think for 9 and 11, all we're going to talk about for about a minute or two. And then you can try. This will be a next time. But the only part I'm going to ask. What would be the relationship of these two particular angles? What's our relationship here? Who could tell us the relationship between these two angles?
Alternate exterior.
Okay, alternate exterior. Which means what? What's the relationship between these two expressions?
3y plus 53 equals 7y minus 55.
Okay. Okay. So that's all we're going to talk about for that problem. That's going to be more of a you try and complete at home. We look at it next week. Same case for the next problem. Again, what's our relationship between the 23x minus 5, 21x plus 5? What type of angles do we have here? Get to the C.
Consecutive.
Almost. Corresponding. The only reason why they're not going to be consecutive interior is because this 21x plus 5 needed to be right there. Not a bad guess, but that's the reason why.
Corresponding with 180, right?
Actually, the corresponding, they're congruent. They're going to be congruent. Although that's not a bad idea because I know they look close. Like if the 21x plus 5 was above this line, then yeah, they would add up to 180. But since it's below the line, corresponding, that's the same spot. So they're going to be equal. That's what's going on here. Any questions? This one could be one at home. Try at home. We're going to deal with some like slope equation. I want us to go through that for a little bit. And again, it's going to be skipping here and there. We're not going to do them all now. Because I just want everybody to get an idea of what you're going to see.
Right.
Because again, we're not going to see each other for a full week after class. I know, due to the crazy schedule. That's why, again, with the recording, that's the reason why I'm having it. You all gonna hear what took place during class today. So we're not gonna do any more with that problem for now. Next thing we want to talk about. Types of slopes. This is a little more recent. So you should have somewhat of an idea of what we're dealing with. So we have the 4 types: negative, positive, 0, undefined. Again, some of the hints were the negative, what that's line going that way, 0, letter Z, and then the undefined, looks like a letter U, up and down, and if the positive, Looks like the P is starting to, the letter capital P is starting to fall on its head. Or, you'd say it that way. Any questions? We talk about the next little activity. The next little activity is just a matching activity. So we need to figure out. If you would do that on your paper, basically we could just do quick, like, which one's what? So,
That's
First one.
First one is positive,
Second one is 0.
third one is undefined, and fourth one is negative.
very good.
What?
And you want arrows. There we go. That'll be it. Good job. Questions? That part's pretty easy. Let me see what we are. So I think for these next ones, it's going to be a we do, you try. We do, you try. But that's going to be a you try on your own deal. And I'll show you what we mean. You're going to see by the next slide. Okay, with this next slide, well here, load one is slope. Now be careful. Just the slope. This is more what we've been doing earlier this week. So the slope, of course, slope M, up, go down, then left, right. So always start from the point on the left. I mean, you could start from the point on the right, but I think the point on the left is easier. So this point right here. Go from this first point to the second point. Are we going up or down first? How far up, Alex? How far up are we going to go? 4. Went up 4. So in our numerator, oh, I already gave it to you. Plus 4 is our new, so going up 4 is our numerator. Up or down is the numerator. Now going up, is that positive or negative? Positive 4. Now, what about the second part of the problem?
You go to the right ones.
2 times to the right.
It's a little hard to see.
Yeah.
I thought it was 1, so.
No, and that's true. It did look like it was 1. Let's make that view even bigger. That might be a little better. Might be. So then we went 2 to the right.
Positive.
So it will be positive slope in the end. Now, can we simplify the 4 over 2?
Yeah.
Yeah.
Okay,
You get to.
slope equal 2. Slope is always that letter M.
It's easy.
M is 2. This other one, you can actually try at home. I mean, unless, did anybody try? I'll have you all try this one very quick, and then we're gonna talk about linear equations. So, right away, is it positive or negative?
Negative.
We're gonna have some type of negative slope.
So we went up 2 and then we made up left. So 2 would be -4.
Okay. I hear what's going on here. We got two different situations.
You have to count. That's gonna be negative. And you go to the right, 49.
Okay.
Well, I think that's a positive for you.
Okay. All right. So we heard one person say down 2, which is -2.
How? Can you keep this simple?
You definitely can simplify. You're right.
I mean, I got a negative, what kind of decimal number?
What type of decimal number did you get?
I got a negative 0.5.
All right. Now, okay, so let's see what, all right.
It's negative 1
Is it right?
-1.5 or -1/2?
I think it's negative 1.
I think it is.
1.
All right. Now, Jason, you said something about going up and left, yes?
Yeah.
What happens if we did that? What happens if we went up 2?
You get positive 2.
You get a positive 2. But then you said you went, what was next? How far to the right or left did you go?
4.
Which way, right or left?
Left or right?
Oops, actually, I should have put these guys. Hold on, let me write this a little different. Boom, boom, boom. You went 2 up, and then left 4. Let me make this, let me give you all a little more space here.
So is it 2 divided by negative 4?
Okay, and what would we get if we did that?
The same thing.
You will get the same thing. So that's why, ladies and gentlemen, that's why when you both said how you did it, I didn't want to say you guys, either of you guys were wrong. Both of you guys were right in the end. Well, it was 80. You went from this point down, right?
Yeah, because you told me how to do it, so that's why I went that way.
All right. But then, Jason, you went from this point up. And in the end, you both got the same answer. So it really doesn't matter. I mean, for the most part, we usually start from the left, go to the right. However, you knew, okay, I went up, but I have to go to the left. So you're going to still get a negative slope. So everything's still going to wind up as a -1/2 in the end. That's the reason why I didn't want to say either of you guys were wrong, because if you both were right in the end. So yeah, go ahead. So good job. Okay, questions on that problem here? Anybody have questions on this problem? All right. What's that? Number 1 real quick. Oh, what happened here?
Oh, okay.
No worries. Okay. All right, this one. Remember, you could label x1, y1, x2, y2, or x2, y2, x1, y1. Either way, it wouldn't matter. Just be very careful with our negatives, especially this problem right here. Because when you do your setup, I want to talk about this one for a moment. So you do your setup. Y2 minus y1, x2 minus x1. Y2 was what number? Negative 5. Now, y1 was what number?
-3.
Do I leave it like that? What do I need? I need something else.
You need your x's.
Okay, that's 2, but I also need something else.
Parentheses.
That's better, especially for the -3. Because between y2 and y1, one sign is always between those two values, no matter what they are.
Minus.
You have to have that minus sign. That's super important, that minus sign. Now for the x's, it's not going to matter as much. Because your x, you got 6 minus 0. So minus negative. That's the setup. But then, here's what happens. So we have 6 minus 0, but what's 6 minus 0? That's our...
6.
Now, 5 minus -3. This is where we really have to be careful. Minus negative. What's that? Be careful. When you're doing a minus negative, what's really taking place? In the end, it's going to be a -2 because... listen up. This is for everybody. All right, so Andy, Des, did you both get this part right here?
Yeah, it's just.
That minus negative becomes a positive. So
And -2 is 6 is
What third?
-1.
in the end, it'd be -1/3. Again, minus negative. That's a positive. And then -2 over 6 simplifies -1 over 3. I'm just going to separate our problem here. Now, number 4, that one you all can try on your own. I'm not going to review that one for now. I really want to start talking about the lines during the last little bit. So, questions? Any more questions on? I give you 2 points. How to get the slope? Are we good?
Yes.
Back row, are we good? Positive. Again, watch your signs, and especially that second number. Parentheses might be a good idea, especially when that second number is negative. Okay. Going forward. Now for these, we're going to zoom out a little. Now what's going on with this type of problem? basically we just talk about, okay, you get your slope. You see you went up 1, and then you went right 3. Whoops. You went up 1, right 3, up 1, right 3, and so on, kind of like it stairs. Now, this point right here, this is your point. So if you went that 1, 2, 3, 4, 5, this is the point. 0, (-5). That's your y-intercept, this value right here. The y-intercept denoted by the letter B. Now, you may get something like this, I don't know. Oh, that's other direction. Yep. So, we'll do one real quick. We're gonna skip the one that's immediately below this problem. I want us to talk about the next problem. So, this one we're going to do a skip because I kind of gave you your information. So, this one we'll talk about next time. Okay, this one I want to talk about a little more. So, look at each point. Let's say, pick any point we start. We'll start at this point here. Now, how far down did we go from between points? You can tell us how far down did we go between our points. Went down 4. So when we go down, is that a positive or a negative? -4. And then how far to the right? Just went 1. So your slope would be -4/1. But what does -4/1 simplify and become? How do we simplify -4/1? It's just -4 in the end, yeah. So your n is -4. You can write that. And I forgot to denote that down here. Which one was n, which one was b. Now, the b, where does this line here, what point on the y-axis does that line cross? Very good. This is -3. So that's your n, that's your b. And the slope goes here, y-intercept goes here. Now, some of us, you could write this as y equals -4x minus 3. I will accept. Yeah. You can write it that way too. But that's basically all you. That problem, look at your slope, then do your counts, and then look at where that line crosses y-axis. Here we went down 1, 2, 3, 4, and then to the right 1. Any questions on that problem? I think the other problem that we skipped was actually easier. All right, now, a couple things I want to do during the next few minutes. I want to talk about, really quick, This is more like memory lane. We recently did these types of problems from earlier in the week. We talk about you're going to get a slope and a point. You solve for B first. Line B. And then you replace only M and B. You've kind of done that a little bit. This is just an in general. But I do want to talk about actual maybe one problem like this, or like perpendicular parallel line. All right. I know we have about 10 minutes, so I'm going to try to gun it as fast as we can. Okay. Let's look at. We'll do this first one real quick, and then we'll talk about parallel and perpendicular slopes. All right, this first problem. List your variables as always. So if you're given a slope and a point, list what you know right away. So which 3 out of the 4 do we know right away?
M, X, and Y.
M, X, and Y. What is M?
M is 2.
X.
-3.
Y.
1.
Now, let's go to our equation. What's going to go in that first box?
2.
Careful.
One.
Yeah.
Okay, so the Y is 1. What about the M?
2.
The B? I mean, not the B, the X.
-3.
-3.
Okay, now, do we have enough information to solve for B?
Yes.
We sure do, because what's 2 times -3? What's that? 6.
-6.
Remember that sign. So it's -6 plus B. Now to get B by itself.
+6.
Now you get your 6, yes. That is good.
7.
Now, final result. We're replacing M and B. So, what are we going to put here?
2 and 7.
2 and 7.
That's all you do. So your final result will be Y. It's 2X plus 7. That's what we have going on here. Now, that's regular slope. I'm just going to look at the other 2. You could try. Just watch your multiplying with fractions, notably with not the next problem, not so much this problem, but still do your list. Okay, music's too loud.
Just to do this thing.
We'll just talk about the list real quick, but then you're gonna try on your own.
Oh, -1.
-1/4. So really watch your signs here. So it will be -2 plus B. So 2 equals -2 plus B. How'd you get the 4, Des? What did we do? Okay. Bingo. That's where a mistake would take place. A lot of people see -2, they make it 0, but that's not a 0, that's a 4. Careful.
Sorry, Y equals -1/4x.
Yeah, you keep the M. Yeah. gotta keep that in there. All right, I'll hit it real quick. Well, in a moment. All right, just make sure. So let me, I'll just check and make sure you got it. Okay, so if it was -6, you gotta add 6, add 6. Yeah. All right, really quick. The last thing I want to talk about before we go with the parallel and perpendicular slopes. All right, real quick with them. All right, no, you can try that one on your own. Yeah, I have been recording. That would be next time. Now, parallel lines versus perpendiculars. Well, we'll talk about this more next time, but I really want to talk about it. I want to talk about it a little bit here. Now, parallel. So I know we're skipping like several slides. I'm going to go one more. Yeah, we're good. Okay, with the parallel, what do we know about the parallel slope? Same or different?
Same.
Same. Parallel slope is the same. Now, this is written a little different, but you're going to see why this might be an option for some of us. So, parallel, that means same slope. Now, this -4, don't worry about that one. Put a line through from there. Oops. Now, here's why this one might be a nice idea. The y, the m, and the x. Because when you start from B, then, you know what? Your order is the exact same. You see where we're going with this? The y, okay, that's fine. The n is 1/3. The x, but the key thing is, you just go in order. You just go 1. Whereas how we had it before, we had the n, the x, and the y, that could have been almost totally backwards. All right, I'm going to leave it like that. You all know the rest of the way. The last problem on the next slide, the one thing I really want to mention, the perpendicular slope. Yeah, you have, some of us forgot that move. This is your original slope. The original. What will the new slope be if we're going perpendicular? And would it be negative? Yes. Okay, listen up. Yep, you too. I'll probably put this recording on. Again, -2/3. You have to flip and change. Flip and change sign. And then, of course, y and the x be the same. And then you're back to where you were. You're back in business. Y equals mx plus b. 5 equals 3/2 times -6. And you're actually gonna get a pretty much value for B. But at this point, be careful because 3/2 times -6. 3/2 times -6. Oh, I want to check that real quick. Anybody try that? So 3 times -6 is -18. -9. That's all right. 9. All right. There you go. All right. See you next Friday. Yep.
This is the second one, Parker.
Wait, so we just got introduced to this, right? Right now, right?
No, we did this last class.
Well, I don't remember because I'm doing it in Miss Edwards' class as well, so it's confusing.
Gotcha.
To remember which class.
Yeah, no problem.
Do you know the stuff will be?
I don't know off the top of my head. No, yeah, I don't know yet.
Thank you.
All right, thank you.